Last time we learned how to make the trend line. Today we're going to elaborate on that. So this is a new data. It's about cars, type of vehicles. It always makes sense to spend a few minutes to figure out what the data are talking about. So these are different cars, different specifications. Suppose we want to talk about length and width. These two variables make a scattered plot with this one. The length is always, the first one is x-axis, so this is the length, and second axis is the width, so that's length and width. I can center it a little bit, so you right click on the numbers here, format axis, and the minimum is then at 100, let's say. Also a little bit better. Here also I can format it. I don't like the way it looks. Format axis equals start from 50 here. So this will be data. Last time we learned how to put trend line. You can close this communication window. We can go through plus, or you can just right click on any of these dots, right click, and then a similar communication window appears. In this case I want to do add trend line, click on it, and the same thing here happens. Last time we learned how to do display equation, which we like, that's the equation, and then additional little thing today is the R square. Okay, so this we will move here and discuss a little bit. So what this tells us is, besides the line that we studied before, it tells us what is a correlation. In this case, R is a correlation between the two quantities, and R square is the square of correlation. The closer to 1 the better, so when R square equal 1, this will be perfect correlation, it will be perfect line. R square equals 0 is the worst one, that would be completely scattered and random dots. So we say that coordinate x is a correlated coordinate y is if this R square is closer to 1. So this is an extremely important and very commonly used feature in statistics. Sometimes people abuse it, but you're going to see it in real life. People are correlating all kind of different quantities. So another thing we're going to learn now is how to take correlation with more than 2 at a time. Suppose I ask you the following question. Out of these several features, horsepower, city mileage, highway mileage, weight, wheelbase, length and width, which two are the mostly correlated? Which two quantities are most strongly correlated to each other? And also which two quantities are negatively correlated? That means when one increases, the other one decreases. Now you could do that by taking 2 at a time, these two, these two, these two, and spend a few hours making all these charts, or there is a shortcut in Excel. So you go to data, you go to data analysis, and then you look for the correlation. See, correlation is that one. You click on correlation and communication window appears, which is very self-explanatory. It says input range, so it is the data we want. So we said we're going to start from horsepower to there. So you have to highlight these. You can split the screen if you want. If data is small enough, you can just highlight all of them. And common mistake now is if you don't click on labels in first row, if you OK it, the following error will appear. Input range contain non-numerical data. What happens is Excel uses these first row and thinks it's the numbers because we didn't tell it that labels are in the first row. If you OK it now, it will produce correlation table. Very powerful tool, because in a couple of seconds we can get a snapshot of all possible correlation and connections between different variables. For example, the highest number here is 0.95, highway mileage versus city mileage. The highest negative correlation would be negative 0.71. So, no, negative 0.74. So, which kind of makes sense. The heavier the car, the worse city mileage it is. Negative correlation means that it's negatively correlated. These numbers here are very closely related to r square, because r square will be just one of these numbers square. For example, if I take this number, negative 0.7, equal, make this one to the square, we get 0.559. That will be a correlation between these two. Let's check it out. City mileage versus weight. You can go to original data. There's a city mileage and there's a weight. These two variables. Actually, I'm going to copy and paste this. Control C here, and I'm going to take a weight and put it here actually first. So if I take these two, the correlation table tells us that they are negatively correlated. You'll see what happens when you plot them. You highlight these two, you click on insert, and also as you can see, now the line is going down. That means the heavier the car, the worse the mileage. If I right click and put a trend line, if I put equation and the r square, it will be 0.559, which is exactly what we got here, 0.559, because that is the square of this number. Okay, so that's how we do it. This is very common communication in statistics, and people using statistics. You're gonna see this with all kind of different variables when people are looking for positive or negative correlation, because it helps us predict future, the sales and other things that you're gonna see in real life.